zero and negative exponents. Let's fill in the chart. It says use the power of a quotient property to simplify each expression. Write the quotient as an exponent. So the power of a quotient property means what do we do when we divide? What do we do with the exponents when we have like bases? We know that we subtract. So in our table, that first expression, it says 3 to the 5th divided by 3 to the 2nd is 3 to the 3rd power. Okay, which is true. Okay, we know that when we subtract the exponents, 5 minus 2 gives us 3. So now let's continue down the table and do some more. So 3 to the 5th divided by 3 squared, or excuse me, 3 cubed. So we end up with 3 to the 5 minus 3 is 2. Continue down. What do we do with those exponents? 3 to the 1st. Start to see a pattern happening. So now we have 3 to the 5th divided by 3 to the 5th. If we continue with that idea of subtracting our exponents, we end up with 3 to the 0. So that's something new. Some of you did remember or ask about this problem on our last problem set, on problem set 1.2. We did have a question where we had to subtract our exponents, and we ended up with 3 to the 0, and I did have a conversation with some of you about what that equals. So see if you can remember before we move on. So it says, what expression did you write for 3 to the 5th divided by 3 to the 5th? And we wrote 3 to the 0. So what exponent did we use? Okay, we used 0 as our exponent. So let's keep some thoughts in mind here. So using factored form, find the value of 3 to the 5th divided by 3 to the 5th. So meaning, let's expand that. So we have 3 times 3 times itself. Whoops. Sorry, my stylus is moving things around here. Whoops. Times 3. So we have 5 3's, again, divided by 5 3's again. Okay. Now let's talk about this. What's 3 divided by 3? Anything divided by itself is 1. 3 divided by 3, there it is again, is 1. 3 divided by 3. What's happening here? 3 divided by 3. 3 divided by 3. Anything divided by itself is 1, so what are we left with? We're left with 1. So based on your findings, what can you conclude about 3 to the 0 power? 3 to the 0 power is equal to 1. So it says, make a prediction about the value of any number raised to the 0 power. So what if I had 2 to the 0 power? Or what if I had a negative 5 to the 0 power? Or what if I had x to the 0 power? What would your prediction be? Okay, so it does say, use a calculator to check your prediction for several numbers. Is your prediction right? So when you go to your calculator, if you put in 2, and remember where our exponent key is, it's that little caret key or that little up arrow. So if you did 2 to the 0 and you hit equals, you should get 1. What if you put in a fraction? 1/2 to the 0 power. Put it into your calculator. You should get 1. What if we put a negative in? Make sure you put your base, which is, say we used a negative 3. Put it in parentheses to the 0 power, and you should get 1. Okay, so your prediction for all of these, any number raised to the 0 power is 1, even if you have a variable. Okay, because a variable represents any number. Okay, let's go ahead and flip the page. So, a non-zero number raised to the 0 power is equal to 1. And if you can't remember that, that's okay. Type something into your calculator. Okay, pick a number, pick a nice number. Say you picked 2. And type it into your calculator. 2 to the 0 power, 1. Okay. So now it says simplify each expression and evaluate. So we've got to find the value where applicable. So what do we have here? I always ask, what's the base? 7. What's the operation? It's multiplication. What do we do with the exponents? We add them. So we would get that, 7 to the third power. Go right to your calculator. 7 to the third power means 7 times itself 3 times. You should get 364. All right, wow, look at this craziness. So let's deal with this for a second. Let's evaluate this much here. What's 3 times 10 squared? Well, 10 squared is 100. What's 100 times 3? 300. Plus, now let's evaluate this much. 2 times 10 to the first. Use your calculator if you need to. Use your mental math skills. That's going to give you 20. Oh, let's do this one, mental math, just because. What is anything to the 0 power? It's 1. So what's 8 times 1? 8. Now let's add these up. 300 plus 20 plus 8, 328. So that expression looked kind of crazy, but when we broke it down, not too bad. All right, let's look at this one. So we've got our bases. Our base here in the numerator is 4. What's the operation? Multiplication. What do you do with exponents when you multiply? You add them. 4 to the 8th in the numerator divided by 4 to the 8th in the denominator. When you divide, okay, what's your base? Division. What do we do with exponents? We subtract. 8 minus 8 is 0. Oh, what's our new concept that we learned? 4 to the 0 power is equal to 1. All right, this one's written a little bit differently. So let's take order of operations says do what's inside the parentheses first. All right, so we have a to the 4th divided by a to the 0. So ask yourself the question, what's your base? A. What's your operation? Division. What do you do with the exponents when you divide? You subtract. What's 4 minus 0? 4. Now let's finish it up. Times, the rest of the problem says, times a to the 3rd. What's your base? A. Multiplication. What do you do with these exponents? We add them. A to the 7th. Using the quotient and powers property to simplify each expression, write the quotient in exponential notation. All right, so we're doing the same thing like we did on the front. So we've got another little chart. We've got division. So ask yourself, what's your base? 4. Divide means to subtract the exponents. So 5 minus 4 is 1. Next one in the chart, 4 to the 5th divided by 4 to the 5th. This should look kind of familiar. What's your base? 4. 5 minus 5 is 0, right? Ask yourself, what does 4 to the 0 power equal? We just learned it. It's equal to 1. But let's keep going with this chart. My base is still 4. I'm still dividing. And I've got to subtract the exponents. 5 minus 6. Oh, 5 minus 6 is negative 1. Okay, so we've got some negative exponents. You guys have seen that, but we're going to expand on them a little bit today. Last one in the chart, base is 4, still dividing. Subtract your exponents. 5 minus 7, negative 2. So we start to see a pattern here. So 4 to the 2nd to the 1st, 0, negative 1, negative 2. Let's see how this is going to help us. It says, what expression did you write for 4 to the 5th divided by 4 to the 6th? We wrote 4 to the negative 1, which was this second to last line there. What exponent did we use? We used a negative 1. All right, so now let's expand it. Let's go to the next page and let's expand this out. It says write it in factored form. So 4 to the 5th means 4 times itself 5 times, all divided by 4 times itself. It's 4 to the 6th, so 6 times. 1, 1, 2, 3, 4, 5. Oops, gotta put one more. I'm gonna make my fraction bar a little bit wider. Now let's divide. 4 divided by 4, 1. 4 divided by 4, 1. You get the idea? You're crossing out the pairs because anything divided by itself is 1. What are we left with? What's left on top? You might say to yourself, well, nothing. But what were we saying all along? 4 divided by 4 is 1. 1. What's 1 times itself? Just 1. Oh, but what's left on the bottom? Oh. 1/4. Well, back here, back on the previous page, we said 4/5 divided by 4 to the 6th was this. We just got that. So let's do one more. Keep that in mind. So write this out in factored form. But look back on your chart. What did we say 4 to the 5th divided by 4 to the -7 was? I think back on our chart we said it was 4 to the -2. So let's expand this out 5 times. And this last one, 1, 2, 3, 4, 5, 6, 7. Let's divide them out. Those are all our 1s. So what are we left with on top? We're left with a 1 on top. Oh, 4 times 4. In other words, 4 to the 2nd power, right? But we said on the front page our chart was this. And we just came up with that. Okay, so now let's compare. So back here we said 4 to the -1 is the same as 1/4. 4 to the -2 is the same as 1/4 squared. See any patterns? Let's see. Okay. So let's sort of summarize. We'll put a little summary in that box there. Oops. Okay. So 4 to the -1 is equal to 1/4. And we also came up with 4 to the -2 is equal to 1/4 squared. So how would you write a to the, you see that on your paper, there's a little negative there, it didn't come through in the Smart Notebook, using a positive exponent. So a to the -3 is equal to, look what we did over here, and look what we did here. What was on top in each one? 1. What's my base? And it was a positive exponent on the bottom. Holy cow! Seems like magic. Let's talk. So simplify each expression. Write your answer using positive exponents. So we don't want any negative exponents for our answer. So again, always ask yourself, what's your base? 13. What's your operation? It's multiplication. What do you do with exponents? That's a -4 in your notes. So -4 plus 7 is 3. Is that a positive exponent? Sure is. Done. Let's go to this one. What's your base? X. What's your operation? Division. What do you do with exponents? Divide. Or excuse me, subtract. So -7 minus 4. So -7 minus 4 is -11. But our directions said only positive exponents. So what can we do to write this in an equivalent form? So meaning the same form, just with a positive exponent. Put a 1 on top and drop it down into the denominator. Makes it positive. So what's happening? When you flip this over, it changes the sign of the exponent. Who knows what it means to flip something over, to flip a fraction over? Think about that word. It starts with an R. Might come back to it in a minute. 9m. I'm going to rewrite this as a fraction. So, what is 9 divided by 3? 3. What's your base here? It's m. Let's put a 1 with that m on top. So now what's 1 minus a minus 2? I'm going to write that out. 1 minus a minus 2. What's 1 minus a minus 2? You guys know, you're always like, oh, that means a positive. So it's 3m. 1 minus a minus 2 becomes positive 3. Does that have a positive exponent? Sure does. Done. All right. I think we've just got a couple more. So this next one, I'm going to write it as a fraction just because I like it kind of up and down. It's easier to look at for me. What's your base? It's division. So we subtract negative 7 minus a minus 4. Good so far? X, negative 7 plus 4. What's negative 7 plus 4? It's negative 3. I have a negative exponent. I can't have that because the directions say only positive exponents. So, equals 1, flip it over, bring it down to the denominator, changes the sign of the exponent. Go ahead, flip it. Holy cow! Look at this one. This one looks a little crazy, but order of operations says do what's inside the parentheses first. So what is 8 divided by 32? Use your calculator. Should get 1 over 4. What's your base? It's n. What do you do with the exponents? 5 minus 0, we just know, is 5. So we simplified what was inside the parentheses, but now it's all raised to the negative 1. Oh my goodness, fraction raised to the negative 1. What have we been doing? We have been flipping it over. How do I flip that whole fraction over? What does the top become if I turn this fraction upside down? 4 goes on top. 1n to the 5th goes on the bottom. Now, once I flipped it over, my exponent becomes positive. Positive 1, because I flipped it over. Okay? Let's hop down to these down here. Let's do this one. What's your base? Negative 6. You're dividing, so you subtract exponents. 3 minus 4 is negative 1. Let's get rid of that negative exponent. What do? We're going to flip it. So 1 goes on top, divided by negative 6. Once I flip it over, what happens to the exponent? It turns to a positive. All right, last one. Base, multiply, so we add the exponents. Base, it's multiply, so we add the exponents. 3 plus 8 is 11. Are these like bases? No, they're not. But I have this guy on top, and it's got a negative exponent. Where can I put it to make it a positive exponent? Drop it down to the bottom. We'll cross over that fraction line, and all of a sudden, it makes it a positive exponent. Leave that one there because he's positive. Drop this one down to make it positive. Uh-oh, what's left on top? 1. Nice job, guys. Whoops, we got to keep going. I missed, because I didn't see it on my screen, this is a negative here. So we got to back up a little bit. So let's back up a little bit and clean that up. Okay, the top is okay, but the bottom is 5, and it's 3 minus 8, so that's negative 5. Okay, so now this guy's negative, so change where he is. If he's in the top, bring him down to the bottom, and it makes it a positive exponent. This guy's got a negative exponent. Change where it is to change the exponent. If he's on the bottom, bring him up to the top. Now, are these like bases? 5 and 3? They're not like bases. Leave them alone. Now we're done. Nice job, guys.